Collins Maths Frameworking, Book 3.3, Chapter 10, 10.2, Surface Area of a Cylinder. To help me with this, I've just got a cylinder. Okay. So I've got this tin of tuna. We tend to imagine cylinders much taller, like a can of Coke or something, but they can be short and squat like this. So here's our cylinder. It's got three sides, three faces. So it's got this top round face, the bottom round face, and the reason I'm holding it a bit strange is because of this round shape here, and it's got a label. And if I was to cut that label, which I did, and take that label off, flatten it out, you can see it becomes a rectangle, or it would have been a rectangle had I been a little bit neater with my cut there, but never mind. We get the idea. So we've got a round top, round bottom, and this curved surface, which unwraps to become basically a rectangle. Now, the first example in the book, it just says calculate the I can't talk and write, 8 centimeters. It says calculate the area of just the curved surface of this cylinder. So if you remember from my last little video, we were just talking about different kind of formulas for shapes and trying to remember which one's which and what does it all mean. So pi d is the formula for a circumference, and we can remember that because this is the length. Diameter is just a length times a number. So it gives us just a length. And that around there, when we straighten out, is just a length. Or we could do it as 2 pi r. It's the same. Pi d, 2 pi r. So maybe I skipped ahead. Sorry. So this rectangle here, the length of this, the area of this rectangle is this length times this width. Well, that length, if you remember, was wrapped around, so it's this circumference. So let's put the formula for this area of this. Yes, it's length times width, but what is that length? It's the circumference, 2 pi r. And what's this width here? It's actually the height of our cylinder, isn't it? 2 pi r h. Let's put these numbers in. 2 times pi times 3, the radius, times 8, which is the h, the height. So 2 times 3 is 6, 6 eighths, 48 pi. And I leave it in as long as possible. 48 times pi equals 150.79. So that's 151 centimeters squared to 3 significant figures. Awesome. And the next example. Okay, so it says calculate the total surface area of the cylinder. So the total area, let's put A total, is equal to the area of the top plus the area of the bottom plus the area of the curved face. So I've called it top even though it's lying down. So this here is pi r squared. Concentrate. So the area of this is a circle, pi r squared, and the area of this, remember, is the flattened out curved surface. Okay. Equals. So the area of the top and the area of the bottom are the same, obviously. So that's 2 of these, pi r squared, plus, so the area of this curved surface, remember it's a rectangle, it's length times width. Well, this width is actually the height, and this length is the circumference, which is pi d. Well, we've already got it the diameter. So rather than let's do 2 pi r, let's do pi d. Pi d times h. Okay, so there's the two circles, and there's the unwrapped curved surface. Let's pop the numbers in. Equals 2 times r squared. Well, that's 2 meters. So the radius is 1. Oh, I missed out pi. Times pi. Doesn't matter which order that is. Plus pi times d, which is 2, times h, which is 5. Okay. 1 squared is 1 times 2, so that's 2 pi. Plus 2 times 5 is 10, 10 pi. 12 pi units, meters squared. Again, another mistake. So that's 2 meters, that's 5 meters. So the answer is 12 pi meters squared, not centimeters squared. Okay, off you go.